Okay, this is, if you can hear me, this was prepared for another club that I'm giving it. I just shortened it down a little bit and left a couple of lines in. So it's not more than 20 minutes. It's a little bit different from what I gave in 2017. This is encouragement for hams who are not technologists or engineers to do something with their gear, repair something, get some satisfaction from what you're doing. So good evening, ladies, dipoles and stubs. I retired from Raytheon and live in Worcester and North Grafton. Most of you know that story. And I'm a member of Samara, Farah, and a few other things. Okay, let me, presentation addresses simple test equipment for the ham who does not have a technology background and would like to test and repair components of their ham station. With a minimal investment, simple repairs and measurements can be made that will keep your equipment up to snuff, save money while providing immense satisfaction. Many hams are not engineers by trade, but have successfully joined the amateur radio ranks to enjoy all that amateur radio has to give. Some have gone on to find a different career path prompted by amateur radio. I've been in engineering for 60 years and a ham for 47. I learn something new every day. Everyone has the same opportunity to learn. It's all in the approach. I know hams who do not have a technical background, who have built kits, tried repairing things. They rarely get to ask how to test something, how to repair something, or how to measure resistance, current, or voltages. They more or less give up. So building a Heath kit, which many of you did 40 years ago, taught many hobbyists and ham the rudiments of soldering, schematics, wiring, component identification and testing. Military radio schools and ITT electronic courses also cemented that learning. We don't have all of those opportunities today, although there are some radio schools and there are courses even by ARRL on doing things in your shop. But there are many articles and books on testing and building electronics. And there's small kits for building test equipment and SDR radios. They're pouring out of China right now. I got a DO-138 scope 2 weeks ago and realized I already bought one 6 weeks ago, so 8 weeks ago. I hope that this presentation will help non-technologist hams to tread a new path. No, these presentations will not make you an engineer, but they will certainly give you an understanding of the tools, testing methods, and lingo. Testing on an occasional table. A lot of people don't have the space for a bench. Some hams don't have a ham shack per se. It's a dual use closet or in a garage. But if you can make some sort of a small bench to do repairs and tests, if you have little on a room, look at using a closet or a shelf with a drawer where items could be placed when not in use, a pull-down bench in a shed or a garage. Many ideas are discussed in the ARRL Radio Amateurs Workshop. That's by Joel Hallis, who became an SK on November 26, unfortunately. Observant hams will probably note the absence of an oscilloscope. At the non-technologist startup level, a scope is not required. If you have an HF radio with a scope, a pan adapter can be used for displaying certain waveforms. Buying and borrowing and using oscilloscopes will be covered in future presentations. Tools. Some of your hobbies around the house, some of the family's hobbies can yield some very useful tools. Most of them will work fine for ham work. The mix shows most of what I need for repairing things. left to right, small Phillips and flat blade screwdriver set, old style side cutters, long nose pliers, flush cutter, pincer type cutter that cuts wires square on, and crock clips for jumpering signals and power and connecting components temporarily. The soldering iron shown is 40 years old. It's a multi-temperature, uses removable and changeable bits. The same technology used today in most of the irons advertised, including the $29.95 job you see at ham fairs. There are many soldering iron stations. Unless you will be removing surface mount devices or doing RF design and breadboarding, complex units are not required. You will not get extra points for having a $500 SMD rework station. Greg. Solder, a roll of rosin cord solder, 15 thou or 20 thou I've used for 30 or 40 years. A 1 pound roll will last you, it's an investment for a lifetime. I mean, I've had one roll I've been using probably for 25 years at least, especially the 20 thou because there's a lot of solder on it. Using big, heavy, thick solder really doesn't work. You need the flux core 15 or 20 thou, and that will get you through. Multimeter, one of the most used tools in a shack or in the field. The ubiquitous Harbor Freight multimeter costs between $3 and $7, depending on how many coupons or price smashed adverts you have or which ham fair you buy it at. It has around 2 to 3% accuracy depending on range, load, and circuit impedance, and a native 10 megohm impedance to the circuit being tested. Although there are many pocket multimeters on the market, this unit is accurate enough to do a good job for most volt, ohm, and current measurements. It can also test transistors, gains, and battery load. I have several of these. I've never thrown one out yet. The banana jacks increase in resistance over the years. The little dab of WD-40 fixes it for another year. The 9-volt batteries that comes with it from Hong Kong lasts 2 years or more, depending on usage. Analog multimeter. Many analog pocket multimeters floating around. Very useful for quick tests on batteries, power supplies, and general voltages, where low impedance will not cause circuit loading and error. If you notice, that one's got orange tape on the bottom because it's been dropped about 14 times, but it's pretty old. It's a triplet. These analog multimeters were made by Fluke, Triplet, Simpson, and Japanese and Chinese companies. Generally, digital multimeters do not show trending. Analog needles give you a trend as the voltage or current goes up or down. Checking small capacitors for leakage is very easy with an analog multimeter, but not possible with a digital meter, unless it's a digital RLC meter, of course. Analog voltmeters and multimeters can be found in any ham fair on eBay, and it doesn't matter if it's 35 years old. The VTVM, this is the famous Heath V7A, which probably showed up in about 15 different varieties. This is one of the later ones I think this is a FET one. So there are many tube and transistor voltmeters on the market. The Heath VTVM depicted was top-notch for hobbyists in the 50s. Later, Heath and other test equipment manufacturers offered this style of voltmeter using FET transistors and lower ranges. The impedance presented to the circuit under test was the standard 11 megohms. Note that this multimeter, this V7A is actually a multimeter with AC, DC, and ohm ranges, and even has center zero voltage. Accuracy is about 1 to 2%, depending on the range and loading. Pocket multimeters have similar ranges, but measuring signal levels of 50 millivolts requires a constant impedance and better accuracy. The V7A and all its brethren perform well measuring small signals on any radio. For the first timer, it's still a workhorse. The ubiquitous MFJ 259 and its various brothers and sisters. The MFJ 259 was one of the first amateur level instruments to use a microprocessor to read SWR impedance and frequency. The unit can act as a signal source and can determine the location of a short or a break in transmission lines. If you plan to install, test, modify, or build antennas, this type of instrument is a must. And I carry one around in a 50 caliber can, along with a pair of cutters and pliers and a few other things. And it makes it easy to carry and it protects it. One of the problems with the MFJ is you see the red power button? If it touches anything, it goes on. So you have to make sure that when you store it, it's not pressing against the button. Otherwise, it will run the 10 AA cells down. But otherwise, it's a marvelous tool. Okay, there's a couple of signal generators here and a bridge. The top unit is a Heathkit IG5281 RLC resistance, inductance, and capacitance bridge, built by me in around 1982. Building a modern kit, the resistors all look the same. This unit will help you sort them out. Not sure if a capacitor is 0.001 or 0.0027 microfarad, or the inductor in the kit is not marked. This unit will nail it. The bottom unit is a Heathkit 5280 RF signal generator. It has a range of 310 kilohertz to 110 megahertz, built by me in 1982. Both these instruments are downstairs in this basement on my instrument shelf, and they get used. This unit can provide harmonics on any band, even when you don't want them. And you can inject IF frequencies for radio repair, supply signals for testing filters, IFs, RF amps, and frequency counters. Both those units run, each one has two 9-volt batteries in it. And I had the same batteries in both of them for about 10 or 15 years. Probably didn't use them that often. I mean, maybe once or twice a month when I was testing something. So why is the top unit called a bridge? A known component is connected to the ZS terminals, and the unknown is connected to the ZX terminal, called the unknown terminals. The bridge measures the known component. The dial is then turned until the meter nulls. Now the four-sided bridge is balanced. So using the formula with the known component value and the dial reading will provide the value of the unknown capacitor, resistor, or inductor. So in an example, if ZS standard resistor is 10,000 ohms or 10K, and the meter nulls on the dial B at 2.4, 10,000 divided by 2.4 is 4,160 ohms, 67 ohms, or 4.167K. There are many low-cost older RLC bridges and signal generators on the market. You would not require an expensive commercial unit unless you were designing circuitry or setting up a test lab. The Heathkit dummy load. You've probably seen them. They're called the Cantana. This one, I think this one is about 30 years old. Venerable dummy load is found in most amateur radio stations. It's a must-have for testing any kind of transmitter. Without oil, it can handle around 150 watts continuously. For high power, either the transmitting time is reduced or the transformer oil is used. Caution, If you buy a used cantenna at a ham fair or off anybody with oil in it, take the cantenna to your local hazardous waste disposal agency, wash the can out with turpentine or paint thinner, and thoroughly dry the inside. If you need a high-powered dummy load, check ham ads and magazines for suppliers of non-carcinogenic transformer oil. This Heath unit has a built-in RF probe which can be connected to an oscilloscope. This presentation of the test bench would normally be followed by demonstrations of fixing a power cord, a mic cord, or a PTT switch, speaker wires, or an antenna cable. With COVID-19 restrictions, it would not be possible to do a physical demonstration at this time. I hopefully will start in-person demonstrations in 2022. I recommend the ARRL publication, The Radio Amateurs Workshop by Joel Hallis. Unfortunately, Joel died a few weeks ago. It's aimed at homebrewing projects. It has excellent suggestions on tools and how to use them and how to test items. Just one warning for everybody. Stay away from high voltages associated with tube transmitters and high current wiring. Always make sure that all power is off before testing, unless the test involves power measurement or active signals. The main thought here, as presented by this presentation, is repair something, take something apart and put it back together. Ask other cams in your club how to fix things, how to attach something. Soon you will gain confidence and the courage to fix items in your shack, including cat and mic cables, dog cables as well. The great feeling of accomplishment will have you wondering why you did not try it before. If there was ever a ham philosopher, that person might have said, hams, go forth and repair the boards that bind and unsolder the boards that don't bind. So what's next? You need equipment? Check ham fairs, watch eBay, watch ham classifieds for used test equipment. Check with club members who might have replaced older serviceable gear. What are you looking for? SWR meters, eventually an oscilloscope, scope probes and test leads, crock leads, antenna resistance bridge, signal generators, frequency counters, kits for test instruments, QRP kits, HF amp kits, receiver kits, matter transfer units, voltmeter kits, books on digital RF and analog testing, and a few dozen other things I forgot. Credits, ARRL Handbook 2021, Radio Amateurs Workshop, Joel Hallis, SK, Nuts and Bolts Magazine, 2015 article on setting up your test bench. 73s. Thanks for listening.